Thank you for downloading this podcast from Talk Radio 702 and 567 Cape Talk. For more podcasts and more information on your number one news and talk station, please visit 702.co.za or capetalk.co.za.
Choose to make a positive impact. Lead SA.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
28 minutes to 10 o'clock. Thank you very much for staying with us. Chris, good morning.
Hello, Reedy. Good morning.
I heard you coughing a few minutes ago. Are you okay?
It's the usual thing, seasonal thing.
Oh, okay. I had that.
No, I've just come back from Malta.
Mm-hmm.
I was in Malta, in the Mediterranean, for a conference on influenza. Isn't that ironic? I've come home with it. No, I'm just kidding. I don't think I've got flu. Hasn't arrived in this neck of the woods yet. It normally comes in about November. But I've certainly picked up airport syndrome. You know, the usual thing when you get on an aeroplane and someone shares their concoction or cocktail of viruses with you.
Okay, well, I hope that it doesn't develop into anything else, because we want to hear fit and happy every Friday morning. My colleague Lelo Mzaka stopped me in the corridors a couple of days ago. He said, I've got a question for the Naked Scientist. Won't you ask him? I said, no. You do it yourself. So Lelo is in the studio and he's got a question for you. Hey, dear.
Hello. Good morning, Chris.
Hello, Lelo.
How are you doing?
Well, coughing, but I'm okay.
Well, I hope you get better. Look, you know, I've often been told that food cooked using a gas stove tastes better than food cooked using a normal electric stove. Now, having moved to a new place fitted with a gas stove, I now cook with gas and find that the food does actually taste better. Now, is there any fact to this, or is it all in the mind?
I still can't get over the fact that you cook, Lelo. But anyway, we'll talk about that another time.
Well, what are you cooking, Lelo? I mean, more importantly, what sorts of things what sort of posh nosh are you knocking up on your gas stove?
Well, it's usually meat.
Packet meals. No.
It's usually like, your red meat, your fish, and a lot of vegetables as well.
Are you frying it?
No.
Boiling and stuff. Okay.
And with the meat, I actually grill it.
Ah, you see, that might be part of it. Because the thing that makes food taste really good, in terms of what we call really good, and particularly with barbecuing, the reason barbecue tastes so good is because of a clever bit of chemistry that a Frenchman came up with. His name was Maillard, M-A-I-L-L-A-R-D, Camille Maillard, and that was in about 1909-ish, and he coined the phrase the Maillard reaction. And what he discovered was that when you get the temperature to more than about 148 degrees C, then a special chemical reaction happens between proteins, things with nitrogen in them, and sugars, which are on the surfaces of cells. And the nitrogen-containing proteins fuse to the sugar-containing molecules, and you get these very tasty cocktails of molecules made. You also get caramelization reactions. Sugar molecules can link up to make caramels. And those impart really tasty flavours. But the critical thing is the temperature, 148 degrees. Mm-hmm. And that's why when you cook things in a frying pan or under a grill, they develop a very different food and flavour characteristic than if you boil something. Because when you boil things, the temperature can't go above 100 degrees C, because that's the temperature that water boils at and turns into steam. And as you heat the water more and more, all it does is make more steam, but the temperature will not climb above 100 degrees. So I wonder whether your gas cooker is actually imparting a slightly higher temperature locally to certain bits of the food, and therefore you're getting more of these Maillard-type reactions happening, which is imparting more flavoursome food than if you cook on, say, an electric hob, which is going to be more uniform. It's easier to make the whole pot get to the same temperature, but you might not get focal hotspots in your grilling, for example, which would give these nice flavoursome molecules on the surfaces of your food.
Geez, thanks for asking that question, Lelo. Very relevant to me as well. So I'm going to be chewing my food and tasting it with extra care. Thanks, dear.
Cool. Thanks, Chris.
Bye-bye.
Pleasure.
Okay, that's Lelo Mzaka from our sports desk. Let's go straight to the lines. And before we do that, Chris, tell me about fatherhood and its effects on testosterone.
Yes. There's a paper which has been published this week and had quite a bit of attention. It's in the journal PNAS. It's by a researcher at Northwestern University in the States called Lee Gettler. And they were looking at the question of what happens to men's testosterone levels after they get married and after they have children.
Tell.
Well, it's interesting because for a long time we've known that men who have high testosterone levels are much more likely to mate and date than men with lower testosterone levels. But when you do a sort of cross-sectional analysis, you look across the population and ask, well, who are the married men, what are their testosterone levels? They appear to have lower levels of testosterone, especially once they've had kids. So it doesn't really fit together. So what this group did was to go to the Philippines, and they recruited a very big group, 624 young men, and they followed them from the age of date of birth right through, but they used the ages of 21 and 26 to do testosterone levels. They used their saliva because testosterone leaches out into the saliva, so you can measure how much testosterone is in the body by checking the saliva. And they did this saliva test when they were 21 years old, then again when they were 26, and at the age of 26 they also looked at who'd got married, who'd had children, that kind of thing. And what they found is, predictably, at the age of 26, the people who had got married and had children had the highest testosterone levels at the age of 21. So they were obviously the ones that the women were going for. But then when they checked their testosterone at 26, they found that they'd had the biggest drop in testosterone level. So it would appear that when you hitch up with someone and then have kids with them, your testosterone level actually falls. And this is compared with individuals that did not get married and did not have kids. And interestingly, the more time a father was reporting spending with his children, the lower his testosterone had gone. In other words, the greater the reduction of up to 34% compared with the median when the study began. And you might ask, is this a bad thing, and why is it happening? The answer is definitely not. It would appear that men can dynamically regulate testosterone in order to bring out their more nurturing, caring side when they are in a family situation. So you have a testosterone-fueled, charged-up, pumped-up, competitive edge to you when you are not married and you're mating and dating or wanting to. And then once you've got a family, the testosterone level falls because the traits and characteristics imparted by having high testosterone are not the most beneficial ones for rearing a family. And this turns on its head our anthropological view of the evolution of mankind, because historically people always thought men were for mating and getting food, hunting. So hunting and sex, basically. This suggests that actually men have a softer side too, which can be brought out by children.
Wow, that is something else. Let's go to Stephen in Somerset West. Hi there.
Hi, good morning, Reedy. Thanks for taking my question. I've just got two very quick ones, if possible. First one, why when I sneeze, the last sneeze is usually the loudest? And also, why when I yawn, the large majority of the time, you also yawn if we're in each other's company? I'll listen on the radio. Thank you.
Thank you, Stephen.
Hi, Stephen. I'm slightly at a loss as to the sneezing, because obviously I haven't witnessed the effect. It might just be that as you sneeze more and more, you irritate the nerves which are triggering the sneeze more and more, and so they produce a more profound, more vigorous sneeze as the sneezing goes on. But I don't know for sure. So if anyone is a sneeze expert, a sneezologist, let me know if you have a theory on that. In terms of the yawning, there are huge numbers of theories about this in terms of why we yawn and why yawns are infectious. There's a very nice study which is probably the best bit of evidence I've seen so far. He's a guy at the City University of New York, or is it State University? Yes, State University of New York. His name's Gordon Gallup, Gallup, if you want to look him up. He had a paper out a few years ago, and what they did was to recruit university students, basically because they'll do anything if you offer them a free sandwich and a cup of tea. And he got them to watch videos. And in these videos were pictures of people yawning, and they timed how many times people yawned in sympathy with the videos. And what they found is that there was a very strong correspondence between when you watch someone yawn, you want to yawn. And then what they asked the kids to do was to either breathe through their mouths or to hold a cold compress onto their forehead. Now, go with me on this for a minute and it all will become clear in a second. They then repeated the study. The people who had the cold compress on their heads yawned almost 0 times the second time through. The people who breathed through their mouth only the second time round yawned about 100% more.
Okay.
So then you say, why on earth should that make a difference? And this is his theory. The theory is that when you yawn, actually what you're doing is cooling blood plexi in the blood vessels in your head, and this helps to reduce brain temperature. Because when you get very tired and you get sleep deprived, brain temperature actually rises, and that's a known fact. So by cooling the blood down, you're cooling the brain down. If you're cooling the brain down a bit, then you are potentially increasing and boosting arousal and alertness. So if you wind the clock back hundreds of thousands of years, when actually we lived in small hunter-gatherer groups, and we would have lived outside, we would have had poor defences against the environment and predators and other tribes coming to attack us. If you're tired and you're nodding off, you might get attacked. If you're in a group setting and one person's nodding off, it's likely that the other people are getting tired. If you therefore make yawning infectious and other people want to yawn with you, you have this enlivening effect across the whole group, so everyone perks up and becomes much more attentive. And therefore, yawning cools the brain and wakes you up, and by making it infectious, your whole group wakes up, and therefore you're less likely to get attacked and preyed upon.
Wow, that's very, very interesting. Thanks, Chris. Let's go to Sean in Plumstead. Hi.
Hi, hello, Reedy and hello to Chris. My question is, can we carbon date water like we do rocks? And how old is the oldest water on Earth?
How old is the oldest water on Earth?
Well, the way carbon dating works, it was discovered by a guy called Willard Libby. And his discovery was that you can use the fact that carbon doesn't exist in just one form on Earth. There are what are called isotopes. Isotopes are the same chemical, but they have extra neutrons in the nucleus of that chemical. And this makes them radioactively unstable. And the isotope decays, in other words, the nucleus breaks apart, and as it breaks apart, it turns from one chemical into another chemical, and you can use the relative proportions of those isotopes to therefore work out how old something is. And the way it works is that up in the high atmosphere, there is radiation coming in from space that hits various atoms, nitrogen, for example, up in the high atmosphere. And the impact of those radioactive chemicals on the nitrogen turns the nitrogen into a form of carbon called carbon-14. So in the air, there is a relatively constant concentration of carbon-14 because it's being made high up in the atmosphere at a constant rate. When plants photosynthesize, in other words, they draw in carbon dioxide and use the energy in sunlight to turn the carbon dioxide into sugars, they basically lock the radioactive carbon-14 into molecules in the wood or in the plant. When you then use that wood to make something, or you eat the plant, you put the radioactive carbon into your body, into your tissues, or if you're an animal, you put it into your tissues. If you then die and go into the ground, no more carbon-14 is added to your body. But we know how much must have been there to start with, because the amount must have come from the air. So over time, the longer you spend in the ground, the less carbon-14 there will be in your body, and it will decay into carbon-12, which is the non-radioactive isotope of carbon. So if you then get the sample out of the ground, you can compare how much carbon-12 to how much carbon-14 is in there, and this tells you the age of the material, because the decay, the conversion of carbon-14 to 12, occurs at a constant rate. So you can work out roughly how long something must have been buried for, and that was Willard Libby's discovery. Because it relies on carbon, you can only use chemicals that have carbon in them, or substances that contain carbon, to do carbon dating, and you can only go back about 60,000 years at the absolute most with carbon dating. The half-life of carbon-14 is about 5,500 years, so you can only go back about 50,000 years-ish. Beyond that, you need to use other dating measures. And there are other dating radioactive things you can use. There's a lead-uranium system, and there are other various longer-lived longer half-life elements that can be used. So you can't carbon date water unless there's some carbon in the water, or a carbon-containing component in the water that you could use instead.
All right, Mark, Sbusiso, Ronnie, I see your call. Stay on the line. We're back right after this.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
Lots of feedback, Chris. Apparently we've made some people yawn just by talking about it. One says, I yawn when I'm hungry. Another, hi, Reedy, you just made the whole of 702 land yawn. That's from Lifu. And Sipo says, I didn't feel like yawning until you guys said the word. Thanks for nothing.
Oh, I hope no one yawns to Reedy's show. I don't believe that.
You'd be surprised.
Reedy, look, I just realised, I realised we didn't answer the second part of Sean's question, which was, he also asked, how old is the oldest water on Earth?
Yes.
The answer is there will be some water which is millions and millions and millions of years old. We know that for an absolute fact, because people have found it in mines, actually in South Africa. They've been finding water that's routinely 40 million plus years old. You can do that by using isotope studies as well. There will be some water on Earth that's inevitably billions of years old, because most of the water arrived here on Earth from space. We think that comets and things impacting on the early Earth delivered a lot of the water we have. One other thing I realised as I was saying this, I think I might have said that carbon-14 decays into carbon-12. This is wrong. I should have said carbon-14 decays into nitrogen-14. So you remove the carbon-14, the radioactive carbon, from the body as it decays over time. It goes back into nitrogen-14. Just wanted to clear that up.
Well, Chris, I could have corrected you since I know so much about carbon-14 and carbon-12. Eh?
Well, I don't want to leave any errors.
Okay, no, thanks a lot. Let's go to Ronnie in Silverton. Hi.
Hi, Reddy. Hi, Chris. I'd like to find out, I heard there was an article quite a while ago on one of the BBC programs. They were discussing how, for apparent no reason, humans just catch fire. I think they called it human sporadic combustion or spontaneous combustion. Could you explain how that happens?
Hi, Ronnie. We're not sure whether or not this is a real phenomenon. There have been some reports of people having been found to have been consumed, apparently by fire, at home, and just the vestiges of them are left behind. Very difficult to explain exactly how this could happen. Some experiments have suggested that this could be because, say, the clothing that people are wearing, and it usually happens to people who are a little bit on the large side, the clothing could be acting as a sort of wick, so they turn into a giant candle. So something sets them on fire, it melts their body fat soaks into their clothing rather like the wick of a candle, and the fat then burns off. And because the human body contains a huge amount of water, then the water helps to control the rate at which the burning happens and also prevents the fire from spreading to other things. Sounds a little bit tenuous. There's also some theories about how you could initiate spontaneous human combustion. One suggestion is that it's down to a molecule of a phosphorus-containing chemical. I think it's called a diphosphane. And this is produced by bacteria. Certain classes of bacteria can produce this phosphorus-containing molecule. Is it diphosphane or phosphine? I'll have to check that one. But basically, when you go out into marshland at night time, sometimes you see these flares of light go up, and it's dubbed will-o'-the-wisp. And what happens is that blobs of marsh gas, which is methane, come out of the ground, and then they also contain some of this phosphorus-containing molecule, and the phosphorus-containing molecule spontaneously ignites. And this ignites the methane and makes a fireball. There have been studies showing that the human intestine can also contain, at low level, the same bacteria that produce this phosphorus-containing chemical. So one theory is that people have methanogens, methane-producing bugs in their guts. They deploy a fart, which contains a fairly high proportion of methane, and also some of this self-igniting gas. And the gas lights the fart, and the fart lights them.
All right, let's go straight to Dumi. Dumi, you're calling us from Florida. Yes, Dumi, good morning.
Good morning. I've got a 9-year-old son. He can't blow his nose. He's never blown his nose.
He can't blow his nose?
No, he can't.
Okay.
He, instead of blowing, he pulls. So he says he doesn't have the sensation for blowing. So I want to know what is it I can do, because my mother isn't threatened to give him to get his nose unblocked.
Oh, okay.
Yeah.
Oh dear. Do you mean that he physically can't master the art of blowing his nose?
Yes.
Yeah, it's interesting because you'd think that's something that comes to people very, very young. But the statistic is that most 6-year-olds can't blow their nose properly. And it's not till they're about 7 that most kids do begin to blow their nose in an efficient and effective way. I mean, my daughter, who's 5, I was trying to teach her this yesterday, and she tried every possible combination of ways to sort of manipulate the tissue paper, the pinching her nose and blowing all at the same time. And because it's such an important sequence of events you have to get right, young kids find it really quite hard. It's like doing up your shoelaces. So even though he's 9 and should probably be able to blow his nose by now, he might be one of these people who's at the end of the sort of normal distribution, a sort of bell-shaped curve of the population, where some people are just slightly slower to do some things than others.
Wow.
I wouldn't panic too much about it.
Okay, Dumi, I've never heard of this, Chris. I'm speechless. I've never heard of anyone not being able to blow his or her nose. But Dumi, do you get that advice? Don't panic too much.
He might be being rebellious, remember, as well.
Okay.
Yeah.
I mean, kids love doing things that upset adults.
But even
because
at 9,
it gets them attention. Yeah, but the kids love doing things that upset adults because kids are very manipulative.
I like doing things that upset adults.
Well, maybe you should stop blowing your nose. I don't know. But no, if it gets attention, sometimes it actually makes it happen more. It's a bit like biting fingernails. If you say don't bite your fingernails, kids do it more. So it might just be that it's a good way of getting mum to pay some extra attention, and that gets him what he wants.
Okay. I have an email here. Somebody says, Chris, please explain why contraceptives are used to treat ovarian cysts.
Well, certain types of ovarian problems are caused by hormone cycles, because the way that the ovaries work is they're a big bag of follicles. These are eggs which are in a suspended state or a state of suspended animation, and hormones coming from the brain, and specifically the pituitary gland underneath the brain, go and turn the ovary on, and they cause some of these suspended animation eggs to turn into what are called follicles, and out of those follicles come the egg that you can then get fertilized. And because that's under hormonal control, certain ovarian pathologies are therefore responsive to the same hormones that can be used to control your ovarian cycle because of contraception. And so under certain circumstances you can actually make the situation better by giving contraceptives which go to the pituitary in the brain, and they switch off the production of the signals that turn the ovaries on, and this can actually help to suppress the growth of any particular ovarian problems.
All right, thank you very much, Chris. We'll chat to you next week.
Righty-ho, thanks for having me, Reedy. See you soon.
Bye-bye. That's The Naked Scientist, and of course, all our conversations with him are available as podcasts just after 1 o'clock. You can go to our website and download the podcast, or you can also go further and go to The Naked Scientist's own website, www.thenakedscientists. It's a plural because there are many of them. Well, not many, but if more than one. www.thenakedscientists.com.